Alright, I'm going to show you how to do the calculations for making a solution and describe the process of making a solution so you're all ready to go when it comes time for the lab. So we know that for a solution, we can specify how much of the solution we want to make, so that's going to be the volume. And so like in this problem, we have 100 milliliters is our desired volume, and we are making a 0.050 molar sodium bicarbonate solution. So NaHCO3 is our solute. So just a couple things here. When you see the formula for something written after the capital M for molarity, this tells me the identity of the solute. So when it comes time for you to figure out the mass that you need to use to make that certain concentration of solution, you are going to need the molar mass of this particular substance, the solute. So the other thing to keep in mind is when you're referring to a solution, in your lab, I don't want you to call it solution 1, solution 2. We refer to solutions by their concentration. That's like their identity. It tells me how much solute is in a given volume of solution. So I would refer to this solution in future questions and labeling things. This would be the 0.050 molar solution. Okay, so we're making 100 milliliters, so we want to use a 100 milliliter volumetric flask. We are not going to be measuring out 100 milliliters of water. Again, if you look at the definition of molarity, it is moles of solute per liter of solution. So what we want is a total of 100 milliliters after the dissolving process has taken place. And we will address the fact of why we can't measure out 100 milliliters of water. Specifically, that'll be one of the things we'll notice when we're actually making the solution in lab ourselves. So there's going to be some volume change because of the mixing process. And so again, our total volume of our final solution after it's made and all mixed up is going to be 100 milliliters. Again, that could vary depending on what you're assigned to prepare, but for this problem that I'm going to go over, it's 100 milliliters. All right, so volume 100 milliliters. I will be using what's called a volumetric flask. So a volumetric flask looks like this. It has a large bottom and a long skinny neck. There's usually a mark, or there's always a mark somewhere on the neck that you got to look for, and usually the volume of the flask will be marked on here. So this particular example that we're looking at, this is supposed to be a 1 liter flask. You would look for the correct volume. So if I'm supposed to be making 100 milliliters, I want to find the 100 milliliter flask. Or in the lab, if you're asked to make 50 milliliters of solution, you should be looking for the 50 milliliter flask, and it'll say 50 ml or 100 ml somewhere on the neck. So the idea here is that if we want to have our target concentration, then we need to fill up, or we need to figure out how much solute to put in to our solution. Okay, so for this concentration and this volume, we first need to convert this volume into liters so that we can use it with the molarity equation, because molarity is moles per liter. So I do that conversion, 100 milliliters times 1 over 1,000, that gives me 0.100 liters of solution. And notice this little decimal point here means this is 3 significant figures, so that's why I'm keeping the 100 after the decimal point. So that's 3 significant figures for the volume as well. Okay, so if you look at the molarity equation, if I rearrange it in the molarity times the volume, right? So this is the molarity. I've rewritten, when I do my calculations involving molarity, I like to rewrite the capital M as a mole per liter, because that's what it stands for. And so when I do that, I can see that when I multiply the volume times the molarity, that cancels out the liters, and it leaves me with moles as a unit. And it is specifically moles of this solute. So the 0.05 molar solution, 100 milliliters of it contains 0.0050 moles of our solute. And again, this particular solute is sodium bicarbonate. So then, if I'm going to make an actual solution, I need to, well, again, your first preparation is going to be involving a solid as the solute. So as you can see depicted here, I got to figure out how much am I supposed to measure out. So with my calculation here, we know we can convert moles to grams by multiplying by molar mass. This is the molar mass of sodium bicarbonate. So sodium is 23, hydrogen is 1, carbon is 12, oxygen is 16 times 3. So that's 84 grams per mole. So that means that to get 0.0050 moles of baking soda measured out, I need to weigh out 0.42 grams. Okay, so this is the number that you're going to be looking for to find on the balance. So you go over and tear out the weigh boat mass, and then that's what you'll measure out and put into your flask. So again, we're going to look at this picture. We'll pour that solid into the flask. We will then add our solute. I would fill up to about here where the flask starts to get narrow. Put the cap on, mix it, and again, you'll notice a substantial volume change, particularly the larger the mass that you use, the more substantial the volume change will be as the particles become intermingled. So we want to do the mixing, the dissolving process, and again, we're making solutions where we should be under the solubility limit, so we should see all of the solute dissolve. So mix it up with the cap on, mix it, mix it, mix it. And then we want to top it off until we get up to, so the bottom of our meniscus should be at this line. And again, you want to cap it again, mix it again, because as we added some water, that's obviously not going to be mixed in thoroughly and be a uniform solution until we mix it ourselves. And so just to show you a picture of what that flask would look like when it's completely mixed. This, notice, is a 50 milliliter flask, but just to show you the zoomed in, here's the line, the blue line, and then the bottom of the meniscus is touching that blue line. So this is a solution with that volume prescribed. This one again is an example of a 50 milliliter flask, but it would look the same with a 100 milliliter, except there'd be 100 on it and be a slightly larger flask. Okay, so moving along, so that is how to make a solution from a solid, and you will try that yourself. But again, since we're measuring out a solid, you have to figure out the mass that you need to measure out to make the prescribed volume at the prescribed concentration. Okay, so next, if I wanted to do a dilution, so you're going to be asked for your second solution to make a dilution, and so that means you're taking the first solution, you're taking some of it, and adding water to it. So to dilute something means to add water to lower concentration. Now, your solution that you're going to be making is a different volume than the example here, but what we can see is how to execute the calculation. So here's the question here. It says make 250 milliliters of a 0.0010 molar solution. Again, it's the baking soda, so obviously you can't change the solute by diluting it. And then we're making it from the 0.050 molar solution. Okay, so you're not just going to take that whole container of 0.05 molar sodium bicarbonate and add water to it. What we want is, we want 250 milliliters, and we want to make it this concentration, 0.0010. So how we can achieve that is by using this dilution equation. And the dilution equation is M1 times V1 equals M2 times V2. And what this does for us is it, actually, if you think about the molarity equation, so I have it rearranged here. So molarity equals moles divided by volume. And if I solve this equation to get M times V, if I multiply molarity times volume, what that really is equal to is moles. So when we're doing a dilution, we're taking some known number of moles by taking out a certain volume of concentrated solution, and then we're going to add water to it. And so when we make our new solution, we're just adding water, so we're changing the denominator of that molarity equation, we're changing the volume of solution, but we're actually adding it to and keeping the same number of moles of solute. So what we're going to be doing with this problem in order to make your solution in the lab is you're going to be figuring out how much of the concentrated solution do I need to make the 250 milliliters of the new solution. So notice I've labeled out my numbers here. So I'm going to call M1 and V1 that has to do with the concentrated solution. So that's what I'm starting with. So we'll call this our stock solution. And I want to figure out how much of that solution. So I'm not using the whole volume that I just made. I want to take a part of it and I want to add it to a new flask and dilute it by adding water and make a new concentration. So the question asks me for this to be my target concentration, for 250 milliliters to be my target volume. And so all I need to do is really plug into this equation, making sure I get everything in the right spot. So the idea is that, again, my higher concentration solution, I don't need that much of it because it's more concentrated. So I'm going to figure out how much of that I should add. And I can keep these in milliliters. So the other nice trick about this is that although technically the volume in the molarity equation is supposed to be in liters, if I have both of these volumes, if I plug in this volume in milliliters, the volume that I solve for will also be in milliliters. I'll show you that when we look at the calculation. So Notice I put in the 0.0010 molar, so I have these two numbers, M2 times V2, they're right here, and then I have the M1 times V1. I plugged in the concentration units and the volume units just so you can see. I divide both sides by the 0.05 molar, and notice the capital M's cancel because there's one here and one down here, but the unit that gets left over is milliliters, and that's good because I want my volume to be in milliliters, because I mean that's how I'm going to be measuring it out, because it's not going to be, you know, anywhere near a liter. So do the calculation and you end up with a volume of 5 milliliters. So what this means is I'm going to need to measure out 5 milliliters of my first solution, of my 0.050 molar solution, and then add that to a flask. So I've got another picture to show you. There it is. So we're not going to be using, this is a pipette. If you were to use something like this, there's usually a marker on there that, you know, you fill up to extract your liquid out of the flask. We're going to be using a graduated cylinder, so it's going to more look like this, right? You pick, this is not representing the volume that we're supposed to be finding, but this is showing an example from before. So the bottom of the meniscus for this problem, for this solution that we've been asked to make, would actually need to be on the 5 milliliter line. So notice on these 25 ml flasks that the, you know, every half milliliter is what's marked here. So we'd want this to be at the bottom of the meniscus right here, and that would be 5 milliliters. So we'd measure that out. Again, going back to the picture here. So that would go into the new flask, and we were asked to make 250 milliliters in this example. So the new flask needs to have the volume that we are shooting for. So in your lab, I believe you'll be asked to make 100 milliliters of solution, so you'd be looking to make your solution, your dilute solution in the larger volume flask. And then, just like before, you'll be adding water up to the mark. You mix it, make sure the bottom of the meniscus is still at the mark, and then there you go, you've got your new solution. So those are the calculations. There's a rundown of the procedure for the lab, and that's what we'll be doing in the lab itself. So you need to execute the calculations in order to know how much of everything to add to make your solutions.